This is the second video of Module 5. We're going to start at number 7. Please be sure to watch the first video to understand what's going on here, because we're diving right into number 7. So in number 7, I have given a little picture of the dot plot I created in one of my face-to-face classes, and then I took a dot plot from another face-to-face class when I did this activity in class time. So let's just kind of examine this first dot plot from one of my classes. So along the horizontal axis, I have the label average word length X bar for each student. So I have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I went around the class and I asked everybody to just report to me their sample mean from their set of 10 words. And this is the dot plot we created. I also added in here, just for our own understanding, a vertical line here to indicate the actual population mean of mu equals 4.29. Because remember, they told us that if you look at the entire speech, every single word in the speech, the average word length for the entire speech was actually 4.29. So you see a bulk of the dots here from my class were above 4.29, and there were just a small handful of dots below 4.29. So each one of these dots, remember, is one student's sample mean. So like up here is a student who had a sample word length mean of like 6.9 letters per word. Down here is one who had maybe like 5.8 letters per word. Another class, just like maybe my afternoon class or something from last semester, here is their dot plot. And this time, again, it's exactly the same thing. It's just a different class. But this time, the true parameter here of mu equals 4.29 is again this vertical line. But you'll notice every single student in the class actually had an average word length higher than that. So I've just given you two examples of dot plots from two face-to-face classes. Okay, going on then to the question. It says to explain what each dot on the dot plot represents by filling in the sentence. Each dot on the dot plot is a single measurement of the value of the sample mean word length X bar on a single student in the class. So each dot is a different student's X bar from their own sample of 10 words. Number 8 says, let's compare our sample statistic to the true population parameter 4.29. Remember, 4.29 is the mean of the entire population of words. It's mu. So it asks how many and what proportion of students in the class obtained a sample average word length larger than the true population mean. So remember, we have two classes actually worth of data here, but in the first class, if you actually look at the number of dots here, that represents the number of students that happened to be in attendance when we did this activity. And when you count them, I count that there were 20 students in attendance in that class. 3 of those students got a sample mean below 4.29. 17 of them got a sample mean above 4.29. In the second class, it looks like there were 19 students in attendance, and all of them got a sample mean word length higher than the 4.29, higher than the population mean. All right, and I just copied that information down here into our problem. So in the first class, 17 of the students out of the 20 students actually got a sample mean higher than the true population mean. So 17 students out of 20, 85% of them in that class got a sample mean that was higher than the true population mean of 4.29 letters per word. And in the second class, there were 19 students in attendance, and every single one of them got a sample mean that was above the 4.29. So 100% of those students got a sample mean that was higher than the true population mean. Part B asks, if we had conducted a truly representative sample of the entire set of words in the speech, then what would you expect the answers up here in Part A to have been? So we expect sample statistics to look like that bell curve null distribution, where about half the sample statistics are less than the true population mean, and about half the sample statistics are higher than the true population parameter. In other words, we expect to see a dot plot that kind of looks like this, where the students in the class get these sample means, these dots representing sample means, and most of them are near the true population mean of 4.29. Half of them below 4.29, half of them above 4.29. However, remember what actually happened was when I asked the students in the class to pick 10 words and find their sample mean word length, in one class, 100% of the students had a sample mean above 4.29. And in the other class, the huge majority of students had a sample mean above 4.29. It did not come out like this. It seems that somehow the results weren't matching up with everything that I told you should happen back in Unit 1. So what's going on here? All right, so in red here, I have some information about a very important new term, sampling bias. A sampling method is biased if when using that sample method, the statistics from the different samples consistently overestimate or consistently underestimate the population parameter of interest. And let me just note here, this is exactly what happened when I asked my classes to pick 10 words and find the sample mean word length. When I asked the students to do this, they consistently overestimated the true population parameter of interest, right? I had students in the class consistently getting sample means that were higher. They were overestimating the true population parameter, mu equals 4.29. And there was something wrong then with the way they were going about sampling. Their sampling method was biased. Note down here, the sampling bias is a property of the sampling method, not a property of any individual sample. Also note, the sampling method must be consistently overestimating or consistently underestimating the true population parameter to be considered biased. It's normal to have some variability in the sample means, sometimes being higher than the true population parameter and sometimes getting a sample mean lower than the true population parameter. But if your sampling method consistently produces sample means that are higher or consistently produces sample means that are lower, then there's something wrong with the sampling method. If your sampling method is good, then it should be the case that you get a sampling distribution that looks like this, that bell curve where about half of your sample means are lower and about half of your sample means are higher. If it comes out where they're mostly higher or they're mostly lower, then something is wrong with that sampling method. Okay, so number 9, we selected words from the complete speech at the beginning of this exploration. Does it appear that our sampling method was biased? Explain. So yes, it appears our sampling method was biased because in both classes we consistently got sample means that were overestimating the true population mean, 4.29. Explain why this might have happened. Explain why we might have expected that this sampling method wouldn't work. And remember what I did at the very beginning of this was I just asked you to quickly pick 10 representative words. So when I asked people to pick 10 representative words from that speech, the problem generally is that when you see the word representative, you might be thinking representative of the meaning of that speech. This is a famous speech, so a lot of people go through and they pick words that they think have like meaning in terms of the actual meaning of this speech. They might pick the famous words from the speech like fourscore. They might pick the bigger words in the speech. The kinds of words that they tend to not pick when I ask students to do this the first time, they don't pick words like a, it, is, the. They pick words that have meaning in the speech. So since they are not picking words like a, it, is, they tend to be picking longer words. And therefore, their sample mean tends to come out longer. Do you think that if I had, at the very beginning of this problem, asked you to pick 20 words, pick 20 representative words, if I had said that at the beginning of this problem, instead of saying pick 10 representative words, do you think that would have helped with this issue? Well, the answer is no. There wasn't a problem with the fact that I asked you to pick 10 words. The problem was in the manner in which the words were being selected. If I had asked students to pick 20 words, I don't think it would have changed anything. I think they just would have picked more long words. I don't think there would have been a bunch of students picking 10 additional words that were words like a and is and the. I think they would have just picked a lot more words that were too long. So it wasn't a problem with the sample size. It was a problem in the manner in which they were selecting the words. Okay, and then I just made a note about that important concept. It is important, please, to note an important issue about sample size. It's a common error that statistics students make. They think that a small sample size is just automatically bad and a large sample size is just automatically good, end of story. And it is just not true. It is possible to have a small sample size and still have a representative sample. If you have a biased sampling method, a bigger sample size is not going to help with that situation. Now, I will point out, if you have a good representative sampling method, then a bigger sample size is better. It will reduce our margin of error, and we will talk about that this semester. But if you have a bad sampling method, then making your sample size bigger is not going to help anything. If you have a bad sampling method, then basically you cannot trust anything about that sample at all. You cannot trust that that sample is going to help you understand the true value of the population parameter.